Hello dear students, how are you? Today we are going to discuss about electrocyclic reactions. What are electrocyclic reactions? Let us discuss here. Electrocyclic reactions are intermolecular pericyclic reactions which involve opening or closing of ring by conversion of sigma to pi bond or reverse. I once again repeat, electrocyclic reactions are intermolecular reactions, that is intermolecular pericyclic reactions which involve opening or closing of ring by conversion of sigma to pi bond or reverse. These are interconversion between conjugated pholines and cycloalkenes. In pericyclic reactions, sigma bonds are converted into pi bonds, or pi bonds are converted into sigma bonds. Let us take an example. We take an example here. This is our butadiene. This is butadiene. Now what happens? Ring closing or ring opening take place in electrocyclic reactions. Now this bond move to this side and this bond move to this side, so we get product like this. We can write butadiene like this for simplicity. This is our butadiene. Now what happens? This bond shift to this side and this bond shift to this side, and we get this product. These electrocyclic reactions take place in presence of light or thermally. Okay, these reactions take place thermally or photochemically. Now we take another example here. This is our hexa 1,3,5 triene. This is our hexa 1,3,5 triene. Now what happens? This bond shift to this side, this bond shift to this side, and this bond shift to this side, and we get product like this. Right? In this reaction, ring closing take place. Same is the case here. Ring closing take place. There is a rule for electrocyclic reactions which is called as Woodward-Hoffmann rule. So what is this rule? Let us discuss here. This rule states that if there are even number of conjugated bonds, if there are even number of conjugated pi bonds, then reaction is thermal and allowed mode of ring closure is conrotatory. Right? And photochemical condition follows disrotatory. In simple words, if there are even number of conjugated pi bonds, then reaction is thermal conrotatory and photochemical disrotatory. And if there are odd number of conjugated pi bonds, then reaction is thermal disrotatory and photochemical conrotatory. I once again repeat, if there are odd number of conjugated pi bonds, then reaction is thermal disrotatory and photochemical conrotatory. Let us take an example. We have discussed these reactions earlier, a short while ago. Now once again I take these reactions. In this reaction there are two pi bonds. Two pi bonds means even number of pi bonds, and what Woodward-Hoffmann rule says that if there are even number of pi bonds, then the reaction is thermal conrotatory and photochemical disrotatory, right? And in this case there are three pi bonds, right? Means there are odd number of pi bonds. Three pi bonds in this case means odd number of pi bonds. So what the Woodward-Hoffmann rule says that if there are odd number of pi bonds, then reaction is thermal disrotatory and photochemical conrotatory, right? That's it, and we will discuss these reactions in detail in next videos.